This video is about some basic rules of differentiation. Basically, these are just algebraic rules when you have a bunch of functions which you want to take the derivative of. I'll write the function in this column, and I'll write the derivatives dy by dx in this column. We'll assume first of all that u and v are two differentiable functions of x, and the very first function that I want to look at is the sum or the difference of these two functions u and v. So let's say your function y is either a u plus v or a u minus v. In that case, the derivative of y is nothing but the derivative of u du by dx plus or minus the derivative of v. It's very intuitive. What you do is you take the derivative of the first function, derivative of the second function, and put the sign that was there in between. If it was a plus, you put a plus. If it was a minus, you put a minus. So yeah, this is what the derivative of u plus or minus v is. The next type of function, the next type of rule is that of a constant multiple. So here I have a u function u, which is being multiplied by a constant k. K is a constant. So in that case, the derivative of this function is nothing but the derivative of u, and you multiply with the same constant. So basically you can take that constant outside and just worry about the derivative of what is inside. This is the rule for constant multiple of a function. The derivative of constant multiple of a function, it's simply that constant multiplied by the derivative of that function. Now comes the interesting part. If you have your function y as product of two functions u and v, its derivative is not the product of the individual derivatives. This is not equal to, this is not the derivative. I would say I would write it here. In that case, the derivative dy by dx is not equal to du by dx and multiplied by dv by dx. This is not the case. So what is the derivative actually? The derivative is something like this. What you do is you take the first function as is, and then you multiply it with the derivative of the second function, and then you add the other way around. So you take the second function as is, and then you multiply it with the derivative of the first function du by dx. So yeah, this is kind of the product rule. When you have your function as product of two functions, then the derivative of that is given by the first function multiplied by the derivative of the second function plus the second function multiplied by the derivative of the first function. This is the product rule. The next and final rule is that of the quotient. If you have your function as a quotient of two functions, and of course we'll assume that this v is non-zero because dividing by 0 is not possible. So in this case, there are multiple ways of looking at this. When you learn the chain rule in future videos, you'll realize that this is not something new. This can be found using the product rule as well. But let's say we don't know that for now. So in that case, the derivative of this function is again, I'll tell you what that is not. In that case, dy by dx is not equal to du by dx upon dv by dx. This is not the case. So what is the case? What is the derivative of a quotient? It is nothing but something like this, but a little bit more complicated. What you do is you start with the second function v that is there in the denominator, multiply it with the derivative of the first one, that's du by dx, and then you subtract the other way around. So the other way around is you take the first function as its u and multiply it with the derivative of the second function dv by dx, and this is not it. What you do is you finally have a v square as your denominator. So whatever your denominator was, you square that, and that is your new denominator. So this might look a bit complicated, but this all of these can be proved using the definition of derivatives, but we won't worry about that. We will take these as rules of differentiation. These are algebraic rules of differentiation.